EIGRP is Enhanced Interior Gateway Routing Protocol, a Cisco proprietary protocol, meaning it'll work on Cisco routers, but nothing else. We're going to be going over some configuration commands, show commands so we can see what we've actually configured, as well as some troubleshooting of EIGRP. Here is the diagram that we're going to be configuring. Actually, the diagram is configured. This represents the router setup that we're going to be configuring. The autonomous system number is something we're going to have to agree upon for all of the routers. And like all the other times, we're going to use the autonomous system number 100. Again, it doesn't have to be 100. It can be anything between 1 and 65,535. If you're on a public domain like the internet, you would have to get one assigned to you. We've got 3 routers, Palestra 1, Palestra 2, and Palestra 3. These subnets are configured against the routers. We've configured the IP address and the subnet mask on each interface, so the routing tables look like this. Every directly connected subnet is in the routing table right now. What we're going to do is we're going to go in and enable EIGRP to get these routers talking to each other. Remember, they'll establish neighbor relationships, they'll fill in their topology tables, and then they will take their successor route out of the topology table and put it into the routing table. So we're going to go in and take a look at configuring this right now in the simulator. So in the simulator, I have everything configured just like we saw on the slide. The only thing that's not configured is EIGRP, so we're going to go in and do that right now. It's not a bad idea, before I configure EIGRP, to make sure that my interfaces are up. I can do show interface, and I can see Ethernet 0 is up, serial 0 is up. If I do a show IP route command, I can go in and see that the .32 subnet and .8 subnet are added to the routing table. Interfaces are up, everything looks good. Now I'll go in and enable EIGRP. I must go into global mode, again configure terminal or CONF space T if you're lazy like I am. Now we type router EIGRP, and then it wants the autonomous system number. Again, every router with the same autonomous system number that's going to be directly connected will share in EIGRP information. So this autonomous system number is globally significant, meaning it's got to match on each of the routers if I want it to work. Now we have the network command, and I specify the network address. And this allows me to put all interfaces that start with a 99 in network or in the router EIGRP autonomous system number of 100. So every interface on this router that starts with a 99, EIGRP will route for that particular subnet. And I've got 2 interfaces on this router, and both of them start with a 99. So I can go network 99, enter. I just published the network in EIGRP. That's all I have to do at this moment. So let's go in and configure Palestra 2 and Palestra 3. I will go up here, select Palestra 2, same thing, show IP route, check out the routing table, everything looks good, telling me the interfaces are up because the directly connected subnets are showing up in the routing table. Global mode, router, if I can type, EIGRP 100. Again, 100 is the autonomous system number. It's got to match. Network. What do all the interfaces have in common? 99. And I am done with Palestra 2. We'll go to the last router, Palestra 3. Router EIGRP 100. Network 99.0.0.0. Now all 3 routers are configured. Let's take a look at Palestra 1 right here and see our routing table. Show IP route. Now I see 5 subnets in the routing table. Before I only saw 2. These are the 3 that I learned through EIGRP. These are non-directly connected subnets. Let's take a look at this. D stands for, if I look up here, if I ever forget, I can just look right here. Show IP route, right at the top, little decoder there, so you don't have to bring your decoder ring with you. It's got one right here. D, EIGRP, 99.40.0.0. That's the destination subnet. 90 is the administrative distance. Now again, the administrative distance is used when there are multiple paths to the same destination, but different protocols have found that path. So if I had a RIP path to 99.40 and an EIGRP path to 99.40, the RIP path would lose out and I'd take the EIGRP path, regardless of which one was faster. And yes, you can have multiple routing protocols running on one router. Here's the cost. Big cost. EIGRP uses a multiplier to figure out the cost based off the bandwidth and delay on the interface by default. So bandwidth delay by default. Next top router that I got the update from, it's had that information for that long, came in through the serial 0 interface. So it shows me all that information. Let me take a look at some of my show commands here. Show IP protocol. If for some reason my routing table is not showing up or things aren't showing in my routing table, I want to check out and see that I have a protocol running. Verify the autonomous system number. Make sure it matches. I'd also go in here and routing for networks 99.0.0.0. Make sure it's routing for the right network. If I accidentally typed 98.0.0.0, there aren't any interfaces that start with a 98 on my router, so it wouldn't be routing for anything. Here's the next top routers and the administrative distance. External EIGRP is a path or an EIGRP route from a different autonomous system. So external means outside of our autonomous system. So if you have to go outside the autonomous system, the administrative distance would be a higher number. Let's take a look at a couple of other show commands here. The show interface command, again, is something that I would check if I'm troubleshooting. Make sure it's up and up. Again, this is layer 1. This is layer 2. And I'd also check the layer 3 IP information to make sure it's correct if my routing table is not populating. So on serial 0 here, I have 99.32.0.1. So what I would do is I would do show CDP neighbors detail, and I would check out the detailed information here. His IP address for Palestra 2 is 99.32.0.2. That's an appropriate IP address, and I would also verify that I could ping 99.32.0.2. If I can't ping the next hop router, then there's probably going to be a problem with me getting my routing table populated since they can't communicate with each other. If I can ping, everything is good, then I'll go in and check out the EIGRP configuration more closely. I love show run for that. I can use show IP protocols, but as well, show run works great. I just look right here. Router EIGRP 100, network 99, and pay attention to these numbers. If they're not correct on both routers, they're not going to communicate. There are some EIGRP specific commands we can look at. Show IP route. If we had a huge routing table, I could just do EIGRP. I can do show IP, EIGRP topology. And I can see my topology table. Simulator, not 100% accurate on the topology table as it shows every subnet in here as directly connected, but it gives me an idea of what the topology table looks like. Other commands I can do are show IP EIGRP neighbors. And again, I would want to make sure that the appropriate neighbors are in here. If they're not in here, that tells me that it's not able to establish the neighbor relationship for whatever reason, autonomous system number, IPs, whatever, and that's why the routing table is not populating. So if the routing table is not populating and I can ping, I'm going to go in here and verify the neighbor table next. I have brought up this network map because I have gone in and introduced some problems between Palestra 1 and Palestra 2, so they're not populating each other's routing tables. PC1 cannot ping PC2. So we're going to go in and figure out why PC1 can't ping PC2. PC2's IP address is 99.16.0.2, and we get a request timed out. So we're the administrator. We're going to go in and start taking a look at Palestra 1 router and figure out what the heck is going on and why there is no connectivity. The first thing we want to do is show IP route just to check it out because we think show IP route. I don't know what that command does. Show IP route to check it out and see what's in there. 99.8.0.0 is the only subnet going on in the routing table right now. So what that's telling me is, I know there's a serial 0 interface. I'm thinking it must be down. So what I'm going to do is I'm going to type in show interface. And I will look at the status of the serial 0 interface. It says is up, that's layer 1. Line protocol is down. That is layer 2 of the OSI model. So let's see if we can figure out why this line protocol is down. With this layer 2 being down, there's no way that EIGRP is going to be able to function and establish neighbor relationships, so we've got to fix this first and see if that allows EIGRP to do its thing. If I do a show run, I can go in and take a look at the configuration real quick. And I'm looking in here, and I know that interface serial 0 is the side of this back-to-back link between Palestra 1 and Palestra 2 that handles the clocking, and there is no clock rate command there. So what I'm going to have to do is I'm going to have to specify the clock rate. Again, the clock rate sets up the timing for the link in a back-to-back environment. So I'm going to go into that interface and type in clock rate 64,000 and see if that brings the interface up. Show interface serial 0. Line protocol is still down. So if I've set the clock rate and the line protocol is still down, there's only one other thing it can be, and that is the layer 2 encapsulation. Right here it says encapsulation is HDLC. That's Cisco's default layer 2 encapsulation. Again, I'm talking about layer 2 of the OSI model. Both sides of the link must match. So let me go over to Palestra 2 and look at its layer 2 encapsulation. I look at layer Palestra 2 and I see here it says encapsulation PPP, point-to-point protocol. That is a multi-vendor layer 2 encapsulation. They don't match. They must match. So I'm going to go in and go to interface serial 0 and type encapsulation HDLC. And I'll do a show interface serial 0 over here, and I can see that the line protocol is now up. So layer 1, layer 2 is up and functioning. Let's go back to Palestra 1 and check it out from there. Show interface serial 0. Layer 1, layer 2, good. Now we need to check the IP addressing. I'll do a quick look here, show run. I can see the address looks right. Let's see if I can ping the next hop router, ping 99.32.0.2. This is where good documentation would come in handy, making sure I had all the appropriate IP addresses documented, and I was looking at the documentation when I'm troubleshooting this. So I get a ping. Now let's see if EIGRP is populating. Show IP route. It's still not populating. So more than likely now it's a problem with EIGRP. I'm going to do a show run again. And I look here and I see router EIGRP and the autonomous system number is 101. I'm going to check the autonomous system number on Palestra 2 with a different command. Show IP protocol. And here I see EIGRP is 100. So on Palestra 1, the wrong autonomous system number is there. So if I forget the command to go in and change the autonomous system number, all I have to do is look at the running config. I go into global mode. It says router EIGRP 101, so I'll go no router EIGRP 101, and I'll type router EIGRP 100, enter, and here is my network command, network. And one other thing to look for, again, those IPs, that says 98. All my IPs on my router start with 99. So I'll go 99.0.0.0. I've basically gone through all the steps that it takes to reconfigure in the first place. And now if I do a show IP route, I can see that my routing table is populated, and I've gone through and successfully done some troubleshooting on EIGRP. That scrolled really far. So here it is again, EIGRP, next top routers. I've got all the subnets that are not directly connected in my routing table, so it looks good. Now the last thing is to make sure that E Station 1 can ping Palestra Station 2. Ping 99.16.02, success. Everybody's happy. Let's go in and do a little recap of the commands for EIGRP. We've got router EIGRP, then the autonomous system number. Remember, that has to match. I'm not intentionally drawing a line through it. Let's get rid of that. So the autonomous system number, remember, that thing's got to match. If it doesn't match on the routers that you want to talk to, they're not going to make friends and exchange topology information. Network, then the network number. We were using a network number of 99.0.0.0, not a subnet. On the most recent iOS versions with Cisco, you can actually specify a subnet and a wildcard mask. Not available on all routers. Maximum paths, and then the number of paths. So if I go router EIGRP 100 and then specify my network, I can use the maximum paths, max paths, I'll just put max, be lazy, 1, and that will disable load balancing. So that command works with EIGRP. Variance, and then the multiplier. Just like with IGRP, I can put a multiplier here. So if I did a variance of 2, whatever my best cost path was, and any other path up to 2 times as bad as that would go in the routing table, and I would load balance. Traffic share balanced, that would actually load balance if I have more than one equal cost path in the routing table. And then minimum would use the best cost path, but immediately use any additional paths that met the variance condition if the best cost path went down. Again, just slows down the amount of time it takes for convergence, or speeds up the amount of time it takes for convergence. Faster is better. Passive interface, and then specify the interface, like in our situation, Ethernet 0. If we were looking at the router, there was nothing over there, just some computers, actually just one computer. There wasn't a router over there that would be establishing any neighbor relationships. So since this guy's not a router, I would have the passive interface E0 command, and it would prevent Palestra 1 from trying to establish friends or neighbors on Ethernet 0. So some important commands with configuring EIGRP. And not only is it important to remember the configuration commands, but the show commands as well. Show IP route allows us to check out our routing table. If it's EIGRP, we're going to see some D's in there. Again, if you forget, it's right at the top. It'll tell you what D means. Show IP protocols allows me to check out my EIGRP configuration. This allows me to look at my neighbor table. Neighbors are good. If there aren't any neighbors in there, then my topology table won't be populated. Topology will show me my successor route, which is the best cost path. That's the good one. And the feasible successor path, which is basically a backup. It will not show me the entire topology of the network. Remember, only the successor and feasible successor go into the topology table. The successor route also goes into the routing table. Show IP route EIGRP will allow me to view only EIGRP routes if I had a very large routing table, which is possible. And show IP EIGRP traffic. This will list traffic statistics about EIGRP so I can see how much information EIGRP is sending out. List traffic stats. So some very helpful show commands with EIGRP so we can go in, troubleshoot, figure out what's going on. So with EIGRP configuration, we've gone in, looked at the configuration commands, configured EIGRP, we tested it, we did some troubleshooting utilizing all of our show commands, show IP route, show IP protocol, show running config, which I really enjoy, and we did some troubleshooting. We created some problems with EIGRP, then went through the steps necessary to resolve them.